Hello, everyone, and welcome back to the Moonbuilders Workshop series. Today, we have a very special guest named Rein, representing the graph. And Marcus is responsible for developer relations and success at Edge and Node. And Edge and Node is one of the parent companies behind the graph. So today, we're going to be talking about getting started building with the graph on Moonbeam. And specifically, Marcus will be talking about two main ideas. And the first one of those is teaching you how to assess, query, and build with subgraphs that already exist on the graph network. And the second one is learning how to build your own custom subgraph to index smart contracts on Moonbeam and Moonriver. And this will be a hands-on demo. And if you can, it's recommended that you follow along and take these steps, side by side. That's a great way to learn, certainly. And let us know if you have, any questions in the comments, and we'll be sure to direct those to the right place. So thank you so much, Marcus, for joining us.
Yeah, thank you so much for having me, Kevin. It is an honor and a privilege to be sharing information about the graph, and then also how the graph interacts with Moonbeam. And really, it's an exciting time for the graph as a whole. So this is just a good time. So if it's so if it's okay, I'd like to just go into the presentation right now. And Kevin, if you have any questions throughout, I'm totally fine. If you were just seeing something like, to make this a dialogue, go ahead and be like, hey, I got a question about that, because I'm fine, just going through the workshop and having a good time if you are curious about anything. So
sure.
With that being said, let's get into it. I'm going to go ahead and share my entire screen. And a real quick announcement before I go into this presentation. June 12th, which is in a few days, is the beginning of sunrise for the graph. And if you have any subgraphs on hosted service with the graph, they need to upgrade to the graph network. We're going fully decentralized on the graph network. So this is an exciting time for the graph as a whole. So just go ahead, if you're watching this, upgrade to the graph network by June 12th to avoid rate limiting, and make sure your dApp continues operating, because we don't want to have any of that happen. And we want to have your subgraphs decentralized. So now,
and Marcus, it's a pretty easy process, right? Can you maybe
It's a very easy process. Really, it took me under 2 minutes. You simply just go to the graph's hosted service. We could actually do that right now live. We'll go to thegraph.com. And you can see we're trying to be clear about upgrading. We want to upgrade our hosted service subgraphs. We'll go to the hosted service. I won't have any subgraphs to upgrade because I've already upgraded my subgraphs. Of course, you'll sign in here. Let's see if we can do this quickly. There we go, and we're in. And you may just see you have subgraphs that require upgrading, and then click on upgrade. The whole process takes about 2 minutes. It's really quick. And from there, your subgraphs will be on the graph network. They'll have one indexer allocated to them. And then if you would like more indexers to be able to hop in and index your subgraph, you can incentivize them with the GRT token that we have in the graph ecosystem. So that's the announcement. Did I cover that pretty well, Kevin? Anything else to cover on that?
That's great. Easy. Okay. I went through the process myself a couple weeks back, and it was super, super easy.
Yeah, I mean, our engineers really knocked this out of the park. It takes a few minutes. You could upgrade, I think, 50 at a time. So if you're a power user, I think it's 25 or 50 at a time. But yeah, the whole process can be done all at once for either the 25 or the 50, and it takes a few minutes. It's quite quick. So anyways, let's go ahead and go into the presentation. So if anyone is following along, like Kevin said, it is recommended to follow along if you would like. This is the repo and dApp integration. I built this little repo so you can just drag and drop code that can be used in your dApps to go ahead and query the graph network with a subgraph that you find. And we'll go through that process and how to assess a quality of a subgraph that you or I find today in this kind of introduction to the graph. So it is not the answer that enlightens, but the question. This is a great quote that I really like. I like it simply because it brings up my favorite emotion of all time, which is curiosity. I think curiosity is my favorite emotion. And the graph is there to answer that curiosity. If you have questions about blockchain data, the graph indexes so much data every single day. So really what I want to do is just go through how we can go through the graph as a whole and see what data is already there, ready and waiting to answer some questions that we might be curious about. So introducing the graph. So just to give an introduction to the graph, for those of you who don't know what the graph is, let's go ahead and do this right now. This is a quick little scene of what the blockchain might look like, and many different chains out there. They were originally created to be write optimized, which essentially what I mean by that is whoever is wanting to write data and pays the gas fees can do that, and whatever is in that block is horribly disorganized. It could be someone from a different dApp from around the world doing a different thing, a different transaction. It doesn't matter. Once that block is closed up and minted, move it on to the next block, that block is terribly disorganized, which means to make that data accessible and performant for a decentralized application, we have to index that data, essentially organize that data so it's readily available for us to gather and present. There's also not only an indexing issue, there's a read issue where, let's say, okay, we are indexing that data. What happens when there's a huge spike in one certain point of data, one certain entity in that indexed database? Well, there's two real issues. How do we organize that data? And then how do we handle big spikes? And how do we make that performant in a way that is decentralized? Well, there are centralized solutions out there that is kind of a Web 2.5 read solution as well as an indexing solution. And it unfortunately runs into the same problems that we are trying to get away from on Web 2, where we know where Web 2 goes. If we keep on feeding the beast, it will simply just keep on being what we know and trying to get away from. So we do know that there are other options out there, but in terms of production-ready, battle-tested, decentralized indexing and querying, that is the graph. It's the Web3 read solution. How do we read so much data that is organized and indexed in a performant way? That is the graph, where instead of having a centralized indexing solution, there are over 100 indexers around the world. Essentially, they're like little companies of their own right that are organizing data and being incentivized by the work utility token in our ecosystem. So it's very much not about like a line goes up token. It's meant to incentivize action, and it's a functioning tokenomic model that is working today for many of the biggest decentralized applications out there. So that is the graph. So yeah, permissionless, anyone who wants to become an indexer can become an indexer and index this data. Essentially, it's an indexing business and be incentivized by the GRT token. Redundancy, you could have multiple indexers indexing the data that you want. So you essentially have backup indexers that are making sure your data is queryable and being able to be provided to your participants, to your users. And it's really affordable. It's only $40 per million queries. So it's quite competitive in the marketplace as a whole. So that's a quick introduction to the graph. Kevin, any questions about that before we get into subgraphs?
Oh, that was fantastic. I just had a quick beginner question about
Sure.
indexers.
Sure.
Do indexers typically run nodes, for one network, for all of them? How does that typically work?
Great question. So indexers index using software called Graph Node, and that software, whenever a new chain is onboarded, is baked in to the software. And so from there, they all upgrade their Graph Node, and from there, they're able to support these chains. So anytime Graph Node is updated, all the indexers out there could potentially index data that is on any of these chains. So from there, it's up to them, up to the indexers to actually choose to say, I would like to index a subgraph. They're not required, of course, because they're running a business to say, it's, they can decide which chain they want. They can decide which subgraph, because the subgraph, we'll go into the details in a little bit, can be huge. It could have tons of features. It could have crazy amounts of performant requirements for the indexer themselves, and they might just not have the hardware to do that. Versus another subgraph that's relatively easy to index. So it's not really by chain. As soon as the chain is integrated with the graph, every indexer around the world can go ahead and index that subgraph. It's just up to them in terms of the subgraph itself and the quality of that subgraph that really guides their decision.
Awesome.
Yeah. So what are subgraphs? Let's get into that. So essentially, there are two things. They're customizable APIs. Anyone can build them. You can build them. I can build them. They're relatively easy to initiate, and we'll do that later today. They're initialize. And they're also valuable. When they're on the graph network, they're really a public good. They're available for anyone in the world to go ahead and query and use. If we've put work into this customizable API and organized data in a way that is valuable, well, there's ways that we can get returns on that as developers. There's ways the ecosystem can get returns on that. It is very much motivated by the GRT token. And essentially, this little arrow, I'll zoom in here, that little arrow is what we're going to be looking at today. This is taking data from the chains, and this data goes to the graph nodes out there. These are the indexers around the world, and they're doing so in this little pipeline through these arrows. And this little arrow essentially is what we're going to be building today. And we're going to see how customizable that arrow can be. These indexers around the world need instructions. They need to know what they're indexing, and that's what we're going to be eventually building. But right now, we're just going to check out the graph network as a whole and see what they are holding currently. So this is a good little GIF of customizable instructions that the graph is providing with subgraphs, essentially organizing data to be put into a database. And that database is around the world with all of those indexers. And that's nice for a little GIF. And we'll go through these customizable instructions as well. These are the three main files in any subgraph. There is the subgraph.yaml, also known as the manifest. There's the logic, where transformations can occur in the subgraph. If we want to go ahead and transform the data, do mathematics, compute, we can go ahead and do that in the subgraph itself. It's another compute layer. And then actually we store the data in the subgraph's PostgreSQL database and the schema.graphql file. So we'll go through these three files in another workshop later today. But right now in this workshop, we're just going to be looking at schema.graphql. That's the most critical one to understand when we're looking at a subgraph from a high level. So let's get into why that might be in a little bit later. And like I said, subgraphs are valuable. They all exist in a marketplace, incentivized. So yeah, that is the graph network with subgraphs combined. There's right now that number, I literally, since I gave this presentation, I think like a week or two ago, it was at 2,500. The graph network is rapidly expanding because all these subgraphs are upgrading from the hosted service. So I think right now it's at 3,500 just in the last week. So 1,000 jump, which is pretty great. And so now we understand what the graph network is for. It's all those nodes around the world that are indexers around the world, indexing data that we would like to have indexed in a decentralized way. And we provide instructions to those indexers around the world in the form of subgraphs. And that's how we want to manipulate the data. We send it out to the graph network when it's ready for production, and we can get our data back. So let's go ahead and take a look at some of these subgraphs that are on the graph network currently. And we'll go to the Graph Explorer. When we go to the Graph Explorer, we can really start to assess and understand the landscape of the graph network and all these decentralized subgraphs. So when we do that, we're going to go through, actually going through not only just assessing the quality of a subgraph, but we're also going to really design some queries in today's workshop. We're going to send some interesting questions to those subgraphs. And then we're also, you've been given that QR code in the beginning. We can even integrate that query with a decentralized application if we would like to do that. So the first things first in this journey of assessing a subgraph that's already decentralized on the graph network is setting up an API key. So we can actually query that subgraph. So let's go ahead and set up an API key right now. We'll go to thegraph.com and go to products and Subgraph Studio. Subgraph Studio is really a studio environment where we can test and iterate and develop our subgraphs and get them ready to be decentralized. Anything in Studio itself is not inherently decentralized. It's more of just a testing environment where we can iterate. So let's set up an API key here in the Studio. And we can see I've got a few different keys in here. Just simply create an API key. Test key, and there could even be spending limits. That's good in case we use an API key and we want to be conscious of our budget. But yeah, it's that simple. We just create the API key, copy paste, and then we'll reference this API key in just a little bit when we're in the graph network, so we could see where the API key is used. One other thing that I want to use here is whenever you're using an API key, you can restrict that API key to a specific subgraph, just in case someone's skimming your API key from the front end somewhere. You could keep it to one subgraph only, and you could also authorize domains, which is a nice security feature. So it only goes through a decentralized application that you prefer. Just be aware of those security features. Those are quite nice. So now that we have got our API key set up, right there, the Moonbeam test key, let's go ahead and go to the graph network and we'll explore the Graph Network in the Graph Explorer. And here, like I said, there was 2,500 last week. Now there's 3,600 subgraphs on the Graph Network right now, and that is really cool. So we could just go ahead and scroll down here and see each of these are subgraphs. Each of these are customizable APIs that people have developed out there permissionlessly and are existing in a decentralized fashion on the Graph Network. So we're seeing some big names: Aave, LivePeer, BetSwirl, Party Finance, ENS, Uniswap, Lido, Premia. It is Snapshot. So in any one of these, let's go ahead and dive in just to get a quick assessment from a high level of how we might look at this dashboard. The first thing I personally like to look at for a quick understanding of if the data is valuable is just look at the open market. This has 207K GRT on this subgraph, which essentially means people are putting their tokens into this to incentivize indexers to really make sure this data is safe and decentralized. And this has 55K, this has 55K. This is a good amount of GRT on these subgraphs. As we scroll down, we can see there's less and less. So this data, I'm not saying it's not valuable, but generally speaking, in an open marketplace, the market sets the price, and the more GRT generally is on any of these subgraphs, generally speaking, the more valuable it is. Now, it's kind of like, I can't say 100% that someone didn't actually, accidentally spend 1 million GRT on any one of these one day and made a terrible subgraph. That's possible because it's an open market. But just generally speaking, for a quick understanding, look at the amount of GRT or the signal on that subgraph to understand, okay, how valuable is this in Web3? Any questions so far, Kevin? Is that making sense?
Just a quick one.
Yeah.
And it is making sense. Yeah, it's this is awesome.
Cool.
Can the signal be moved around? Like, can I delegate, or place some graph tokens on one, and then next week say, hey, actually, I want to do a different one?
Yep, it's called curation. That's a great question. You curate a subgraph in that you understand Web3 as a whole, you understand the data, and you could look at this subgraph and say, I like to curate. So let's go ahead and just click this one right here. And curators. All right, so we can see right now who's curating on this subgraph, how many shares they're curating on this. And you could signal on this subgraph, which means you're applying curation, you're applying GRT, or you could unsignal and take the money away. There is a thawing period where it's a certain amount of money that you put in and you take out. You can't do it like quick trading. It's meant to be something that you look at. You're looking at the signal. You say, I want this much to be in there, and that's going to have more incentive for indexers to hop in to actually index this. Right now, there's 5 indexers going through this, incentivized by that. So did I answer that question in that? You can put it in and take it out, but there's a thawing period. Okay, cool.
Yeah.
Cool. And so let's keep on going through. So we're on the Graph Network here. We've got the Moonbeam test key. And now let's go one step deeper. And I'm going to use a subgraph that's a demo subgraph that I have used many times for this instruction, but also because historically it means a lot to me because it was the first subgraph that I got introduced to many years ago. It was the CryptoPunks subgraph. I was like, what the hell is Web3? So I went to this subgraph, and we can see there's 3 different subgraphs that are looking at the CryptoPunks, that are looking at CryptoPunks. They at least say they're looking at CryptoPunks. And so we see one has 6.4 GRT, so not a whole lot there, 0 GRT. So we're kind of like looking, all right, not a whole lot of business here, but I'm seeing a Masari tag here. What does that mean? And this one, these 2 do not have Masari tags. Let's dive into what Masari means. Masari, it's subgraphs.xyz. Masari is a core development team that is working with many of the other core development teams working on building the graph. And they are building, I think the total is 800 subgraphs. And all of them are categorized very nicely for developers like you and me to be able to have a standardized style of subgraphs. So with the standardization, there's more power. And here's what I mean by that. These are the bridge subgraphs. They're all under the bridge category. These are the derivatives options, not many there. The perp futures options, the exchanges. This is a much bigger one. You can see all the different chains that all of these different exchanges are on. And what it means to have a subgraph that is under the same category, that in the standardization therein means that we could send one query that we designed using GraphQL instead of sending like 30 different queries, because every single subgraph is different. We're sending just one query to all of these different subgraphs. We could design one query and it's going to work on all of this data. All right, so it is really performant in terms of, or at least powerful in terms of looking at Web3 as a whole and just saying, I would like to answer this one question to all of these different exchanges all at once. And that is super, super duper powerful. And it's decentralized, which is really, really cool too. There's standards for ERC 721s and 20s, generic. Send a query to these, but we'll go into that a little bit later. But just know, whenever you see a Masari tag, that means there's standardization baked in, and that makes the data that's returning just easier to just access and ask questions to, rather than having just understanding every subgraph individually, which would be a lot of work. So, was that pretty clear, Kevin?
Yeah, absolutely.
Cool. I can't see you because we're doing, we're not doing like a podcast thing right here. But
Oh, sure.
If you have a question, I can't see the chat or anything. Anyways, so that's Masari. We could go into that, but what I want to do is go to the very first subgraph that I ever went to, which is this subgraph right here. We understand it's a Masari. Let's go through kind of a mental checklist. The amount of GRT that is signaled on the subgraph, not a ton on this one, not a ton of queries in one day for this subgraph, not a super popular subgraph, that's okay. But this one has a little bit more GRT on it. It's not Masari. Let's go in a little bit deeper. We'll go into here. We don't want to go into the actual developer. I'm going to the subgraph itself. Oh, by the way, of course, I just want to say, of course, the 3 chains, Moonbeam, Moonriver, and Moonbase Alpha, are all available on the Graph network, and we can see all the different subgraphs in there. And that is, of course, a supported networks on the Graph.
Great to see. And, yes. And that's a big deal that you have support for all 3, because people like to test things in Moonbase Alpha. There are teams on both Moonriver and Moonbeam, and those are both production networks. So the fact that you have support for all 3 is a big deal. And I love the fact that you showed how with Masari, right, they're making these standardized subgraphs. That must save like a huge amount of developer time, because you don't need to re-engineer something just because you're changing networks.
Yeah, what I'd recommend for anyone who's curious about Web3 data, like, yes, you can build a subgraph from scratch from the ground up, but there's such a community out there of subgraph developers that have built some beast of subgraphs, and there's so much utility with custom subgraphs with a subgraph developer that knows what they're doing, that can really shape the data in a powerful, powerful way. So before going down the pathway of becoming a subgraph developer, which, if you're building your own smart contract, you do have to deploy a subgraph to it. We'll talk about that in the future. But if you're ever wanting to index like a major protocol, start at the graph.com Explorer, because I guarantee someone else has already started and built for you. Just a little tip on that. And same with Moonbeam. If you have any, something big out there that you're thinking, check the Graph network to see if there's another subgraph out there that might already be indexing that for you. Anyways, let's go into the subgraph itself. So this is the CryptoPunk subgraph, and we can see this is the playground right here. We have the API key right in here, the subgraph ID, the base URL. Whenever we want to send a query, remember our API key before? We just simply have this endpoint that's right there, that's on the Graph network. If you see gateway, it's going to the actual gateway to the Graph network. And all we have to do is drop in our API key right there, and we could send any of the queries that we design right here to this endpoint right there. All it needs is that API key. If we have that API key used, we have 100,000 queries that we could use per month for free. Just know that. So it's really good for hackathons, testing, developing. That's always free every single month. And just know that. So developing a subgraph is easier than ever. Before, even I think about like 8 or 9 months ago, it had a little bit of cost to it. Now 100K free all the time. So let's go ahead and take a look at this subgraph itself and say, hey, what do we know about the subgraph? We can go and query it, of course, but we really don't know the database. How is the database structured in the subgraph? What's it about? Well, let's go to the about here and see if we can find out some more about this. Here we can say, all right, a little bit of information here from the developer, which is helpful. Every one of these subgraphs, like I said, is permissionless. So this developer, CryptoPunks.subgraph.eth, that's this person here, decided to go ahead and luckily place in his GitHub in there for this repo. That's very much appreciated because this subgraph itself, people don't have to drop in their GitHub link, and that means it's not auditable. I would prefer, if I saw a subgraph there, for it to be auditable and be able to see if there's any transformations. Just knowing that if you're going to a subgraph and you want to really understand that data, you can go into the actual code, and that's very helpful here. So we see there's a README. We can understand really what this what the contracts are of this subgraph that are indexing, and just more information from this developer, which is very helpful if we want to keep on building on this subgraph. We could fork it and do it ourselves, or we could take a look at what he has done. Now remember, from a high level, I said the schema.graphql is the most important file. So let's dive into this. If we ever want to quickly assess a subgraph and understand the data therein, we need to understand the subgraph's database and how it's structured. We go to the schema.graphql, and that is how the database is structured. And what we're looking for, the magic word that we're looking for, is these comments. What we have here is let's go through how this is shaped. An entity is actually just basically an object that is in the database, and these are properties inside of the database. So account is the entity itself, and there's an ID of that account. There's also punks owned on that account. Without these comments, without knowing exactly what this entity and property is with the comment, we might have to go deeper, because sometimes the naming is a little bit weird. If I was to send a query to account assigned, what does that mean? What does assigned mean? Well, punks assigned to account, if there's any. That little comment right there clarifies very easily. Just imagine that's not there. Just we send a query to, account assigned. We have to make assumptions of what that is. But this subgraph developer has been kind about putting comments everywhere, which makes a real big difference in just quality of our development experience. So let's design some queries in regards to knowing what these comments are. That's a really cool thing. So let's go to the query, and let's go ahead, and these are all the different entities. These are all the different objects in the database. I'm just going to close these up, and you see these. It's just, if you don't know GraphQL, no big deal. What we have here is a kind of a playground where we can mess around and send some queries. I want to know the top, let's say the first 10 sales. Let's see the ID of the first 10 sales. Let's see if I hover over NFT. I don't know if you could zoom in there. I've tried to do this in different workshops. A little pop-up showed, it says punk being sold. The comments will push through the front end, and so we don't have to go back and forth to the comments. If we click on NFT, we can understand the NFT that's being sold, the first 10 in the database. See, it's building the query for us right there. And let's go ahead, and I also want to filter by something. Let's go ahead and order by, I want to see the very first few, and we're going to do the timestamp, because that's going to be like, all right, when was the first? And we want ascending from low to high, so that's what we want there. And I think this query is ready to go. Let's just send this real quick, and we have that response back. I don't only just want the ID of the entity itself. I want to understand let's get the timestamp of when that was sold. Let's move this up here. You can start to learn GraphQL just by poking around. And do I want to go from to? No, I just want to know the ID and the timestamp of the sale, the NFT sold, and also the log number. Why not? You can kind of see we're already starting to build up a query and see that test response right there. We have a valuable query that we have built through just clicking around, asking some questions. If we ever have questions, we can go to the comments, and we have the endpoint. So in our application, all we got to do is just drag and drop that to the query with the API endpoint right there. And that is really how I go through assessing a subgraph that's on the graph network, building up a query, seeing the response back, and then from there, launching it out with this, okay? So with this workshop, I kind of went through this. I didn't go through the slides very much because I find it more useful to actually just go keep on coding and keep it at least through the actual actions. But we already went through this, just reviewing. Is it Masari? We look at the curation level, how much GRT is on it. We look at the documentation, and that subgraph did have documentation in GitHub, which you saw. The comments in schema.graphql. We designed a few queries. We did some filtering. There's other features in the query section that we can play around with. It's pretty cool. And here are some example queries. If you feel good about tinkering around with these, go ahead, play with these queries. First 100 sales between timestamp this and timestamp that. I mean, I'll just quickly do that here. First 100 sales between timestamps. We can do that with some filtering. 100 sales with the first 10 right there. Let's get rid of NFT. We don't care about that. But here's the where. This is the logical operators. So we want to look at timestamp greater than, timestamp less than, timestamp greater than, timestamp less than. So that's just right there. We can just drag and drop the timestamps that we want, and we can see greater than, less than, equal to, not in. You know, we can put some logic in there. It's pretty good. And this is the playground where we start testing, iterating, seeing if this data is valuable to us, and then from there, if we actually want to bring it into our decentralized application, we just drop it right in. That, let's see, I'm trying to think of those. Oh yeah, I do want to do two more things here. The total value of all sales, total supply, and total number of sales in the CryptoPunks contracts. Essentially what a subgraph can do is look at the data in the history of the smart contract all the way back from its very genesis and do math on all of that data. It can do compute inside the subgraph. As opposed to finding a single transaction with a single data point, it can do it all there for you. So in this subgraph, we look at the contracts entity. This subgraph developer has developed a nice entity that does compute for us. So if we go to the contracts, let's just do the first 10 contracts, and you can see total amount traded, total sales, and total supply. The math is there for you. So that's a really nice feature to have compute inside the subgraph. Of course, you could do this and gather all the data yourself and compute it in a different way. That's totally fine. But if it's really easy to do here and you don't have to worry about it, and you know it's directly coming from the chain, it's a quite nice feature. So anyways, that is essentially querying Web3 data with the graph. Remember I said you could send the same query to multiple subgraphs in Masari. This is a query I designed here. Come on, computer. There we go. That goes to these two subgraphs. And these are both, of course, exchange subgraphs. And if we want to get the TVL on that exact date, I think it's yes, greater than, less than, between that time for curve, as well as for sushi swap. We can get that data back and compare and contrast those returns. And as we can see here, there's 5 indexers on there, as opposed to one centralized indexing solution that are out there. So that is querying Web3 data with the graph. And if there's a little bit of information on GraphQL if you want to learn more about GraphQL. I know that was a lot. GraphQL is its own language, and getting performant with it is something that is a skill. If you're sending huge queries with a ton of information, it's not exactly going to be performant. And if you like, another side note, if you like Python and like to use that language and don't want to strictly for analytics, you can use this library. This is called Subgrounds through the company called Playgrounds. Just go ahead and Google Playgrounds and subgraphs, and you'll find their Python library. Very, very helpful. And then dApps is great for dashboards. If you don't want to develop a front end, if you're a back-end developer and you just simply want to pump the data into a dashboard, dApps was designed to work exactly with subgraphs. And that was it for this presentation. So I'm going to proudly update that to 3,500 subgraphs. And decentralized indexing is real. We're really proud to have a production-ready network that is serving millions, billions. I think we have 1 to 2 billion queries per day we're getting. So it's yeah. And that's all I'll say for getting querying Web3 data with the graph. Any questions so far, Kevin? How you feeling?
That's fantastic, Marcus. I think you need to increase the 3,500 already to 3,600.
Yeah, you're right. I did. That's right. It was 3,600. So yeah, with the sunrise going on right now and all the subgraphs upgrading to the graph network is quite exciting. Where at the hosted service, there was really no avenue to be decentralized. It was a service that was meant to just be there until we were ready to decentralize fully. And that is, well, June 12th. So it's here.
That's it. And what was the link for the best place to go and look for subgraphs on the decentralized graph service?
Yes, it's Graph Explorer. You could explore subgraphs on the Graph network. And so going through here and dive in and see all the different chains and just have fun. Of course,
Sweet.
Moonbeam, of course. So, should I continue on with subgraph development and querying, like actually building a subgraph? Is that what that
That'd be great. That'd be
that.
fantastic.
Cool. So, real quick, if anyone here wants to follow me on Twitter, feel free to reach out. I'm always available. Just ping me. I will get back to you when I can. And from there, I want to also share the repository for this workshop. Let's go ahead and getting a phone call. Do not disturb. Okay, do not disturb. This right here is a repo that takes us through essentially a starter subgraph, and we're going to do it together. So you don't necessarily need to do this if you want. You can follow along, but it is there for you if you need. I did briefly talk about subgraphs, and they look at kind of the history of a subgraph and the history of the data, excuse me. This is an example of CryptoPunks and kind of the data that's stored. It's kind of like a CSV, where it's just stored data, and we're looking at it as a single snapshot if we're looking at a single kind of day, if you will, of transactions. It really does help if we could see in history what's going on. At a certain day, at a certain time, analytics are really fun to do, and doing transformations on the analytics, doing mathematics, compute on those on that data is a good time. So that's really what subgraphs can do, and we're going to be able to do that with a smart contract that Kevin provided me earlier today. We'll do that today. So let's go ahead, and this is the intro. We already went over a lot of that, kind of the details of that. Once again, the three most important files are the subgraph.yaml, the manifest, the logic, which is the mappings. We'll go into the kind of, if we want to transform the data, we can do that. And then the schema, that's the database of the subgraph. So we'll go through that kind of flow. We did look at the schema and the comments in there a few minutes ago. We're really going to start looking at these a little bit more and understanding that better. And then, yes, what we're going to go through is deploy a starter subgraph, and then compare it to a published subgraph. So I know we're going to be using, Kevin, we're going to be using your subgraph, or your smart contract that you're providing. I'm not sure if there's already a published subgraph on that smart contract, but I'll try to bridge what I'm trying to teach here about our starter subgraph that we're going to build together, and then comparing it to a published subgraph with more features. We already looked at that CryptoPunk subgraph that other developer built. We're gonna go back to that one and see what extra features that it has, and we'll actually go into the code and take a look at that. Does that make sense?
Absolutely, that's perfect.
Cool, awesome. So yeah, I know it doesn't. Let's just go ahead and do that. We're not gonna go through this.
And
yeah.
I just checked as well. It doesn't look like there is a subgraph already existing for the smart contract for the Great Escape.
Perfect. So we are going to be able. This is good. We might be able to publish the subgraph on the Graph Network. Nope, I don't have any GRT in the wallet that I'm currently active on. I would have to get my. I'd have to get my what do you call it? The
no worries.
Cold. Yeah, I'd
no
have to get my cold wallet and do all that stuff, and I don't want to do that. I just want to teach. But yes, this could be published on the Graph Network. So what we're going to do is we'll go ahead and go to thegraph.com, and we'll go to products, and we'll go to the studio, subgraph studio, where we can build a new subgraph. And we're going to create a subgraph, Moonbeam. And what's the name of this data?
It's called the Great Escape, but we can just abbreviate it like TGE or something.
Okay, the TGE. Okay, Moonbeam TGE. All right. And this is the dashboard of Subgraph Studio. The subgraph that we have in here will be a subgraph that we'll be developing. It's a rate-limited development environment made for testing, made for iterating. It's really not it's not on the Graph Network, and it won't be just yet. Just know whenever you see the development query, this is meant for development in Subgraph Studio. When we have our subgraph ready for the Graph Network and it's doing all the features that we want it to do, we will publish it to the graph network, and then it goes to the indexers around the world. That's generally the flow on this. We're not going to go through all of those things right now, but let's just go ahead and go through this. So if you haven't installed the graph CLI, you need that to spin up this subgraphs init, and you can do that like so. I've already installed that myself. Let's just, actually, I did npm before. Let's just go ahead for the sake of this, do it again. I'll do it with everybody here today. And from there, we'll go ahead and go through the init, which is the code that will init the subgraph locally on our computer. So we can take a look at it after that. Doing its thing. Because we don't have a hard stop, I'm okay taking a few more seconds on this. And we'll do graph init. Okay, so then we have to see, I don't know if that screen's big enough for everybody, but it's the biggest as I can make it right now. We have to see what protocol we want to be indexing. The graph subgraphs can index Arweave off-chain data, which is pretty cool. Also, any EVM compatible chains, which Moonbeam is. So we'll go there. Also, Near Cosmos, and then Substreams is another technology in the graph ecosystem, essentially able to index more granular data from smart contracts. Pretty much it makes a copy of the entire blockchain and index it in a highly performant parallel way. The tech is more advanced. So I'd say start with subgraphs, and then if you need more granular data that is more rapidly indexed streaming, if you will, go to Substreams. But we're not going to do that today. We'll do Ethereum, and we'll do Moonbeam TGE. It automatically pulls the slug in, and then we'll go through and find Moonbeam. And it's on Moonbeam, correct?
Correct. Yeah, the
correct.
game is on Moonbeam. Yeah,
Cool.
and the contract.
Cool. Awesome. So Moonbeam, there we are. So now we just drop in the contract address, which you provided earlier. This is the Great Escape's contract address. And while we're here, I want to point out one thing that subgraphs index. Of course, it's not going to index everything in the smart contract. It looks at events, and any good smart contract developer has good events in their smart contract. And if we look through the events we already have, hey, we got these events right in here. So we're going to be looking at these different events, these given reset. I'm not sure what these are, but anyone who's actually built this smart contract definitely does. Anyone that knows this edge, this world, this what do we call it? The community, the Great Escape community, they're going to know what these events mean. The Spirit bot, Shakes used, Shakes bot, that's what we're going to be indexing. Those moments are important apparently in this smart contract because an event is being emitted. So that's anytime we are indexing from a subgraph, we're looking at events. All we got to do is copy the address, drop it in. What it does is it goes to the Etherscan, or the scanner of the chain, you know, the Moonbeam scan, and it will continuously try to find the contract name, the start block, and the ABI. Sometimes the Explorer, the Chain Explorer, the Block Explorer doesn't respond in time, so just keep on trying until it gets it, which it did right there. If it doesn't, that's okay. You have to go ahead and find the start block manually, which is annoying, but you know, that's something that is not our fault. It's more just trying to get the response from the actual block scanner. And also the ABI. If you ever don't know where the ABI is, just go into the contract and go to the bottom, and you could just copy paste the ABI, where is it, right here, into a JSON file, and then show the CLI that file, and it'll be just fine. So the start block is where the smart contract was deployed initially. This is where the genesis of the smart contract of this Great Escape was deployed. Let's go ahead and say, hey, we want to understand everything from the very beginning up until today. That's a real cool feature of a subgraph. It automatically correctly names the contract name, the Great Escape, which is pulled from the Moonbeam scanner. And this is the magic. It's going to take the contract's events, those events that I showed you earlier, and convert those into entities in the subgraphs database of the same name. So whatever emits from the smart contract event, and it's named, let's say, I don't know, Great Escape Event 1. In the database, it'll be named Great Escape Event 1. And we'll go through and store everything that's happened in the history of the smart contract right in our subgraph. And that is really cool. So we'll go through and let it do it locally. It's not deploying yet. It's just installing it locally. Any questions, Kevin? Making sense for the most
No,
part?
not at this time. This is making perfect sense. Yeah.
Love it. Okay, cool. And if it ever doesn't, please interrupt. A subgraph can index. I've never seen a subgraph not index. I've never seen a limit of what a subgraph can index in terms of number of contracts. So if you have 100 contracts, 50 contracts, it can index all of them as long as they're all on the same chain. So as long as they're all on Moonbeam, for example, for this subgraph, you could have one subgraph for a zillion smart contracts, which is quite nice if you want to keep things tidy in that way. Many people prefer to have multiple subgraphs for multiple smart contracts. That's just easier in their mind. I would recommend having one subgraph for multiple smart contracts. It's better. And then also when you do decentralize your subgraph in terms of indexing a lot of data, you don't have to incentivize indexers with funds for every single subgraph. You could incentivize indexers with just one subgraph, and it could do all the smart contracts, which is quite nice. So do we want to add another contract? Nope. And we go through these steps: graph auth, cd moonbeam, yarn deploy, and then we can do that. All of these bits of information are in the studio. Graph auth, this is a long string with my authentication. I'm not going to show that on live stream because that's securing my subgraphs. And I've already authenticated my computer. That essentially allows my computer to talk with this dashboard and talk with the graph network. So I don't need to auth, but I will cd into my subgraph, and then I will just run yarn deploy, which this is right in here as well. In fact, I'm not going to run it just yet because deploy pushes this to here. No, let's actually deploy it. Let's do this. We'll do graph code gen and graph build. I know it doesn't say that in the CLI, but essentially if we deploy, it automatically runs code gen and graph build. What code gen is the type safety of the code, and build compiles. So let's do yarn deploy. And we give it a version. 0.0.1 is traditionally what I do. And it's running graph build and graph code gen. Oh, there we go. We are getting an error. That's fun. Let's try. It's always live coding, right? Graph code gen, graph build. Build complete. Let's just run this. It'll be 0.0.1. There we go. Oh, it didn't go through. I know. Let me try one quick debug live. Let's do this live. And let's see what we can do. Come back. Where did that go? Huh. That's interesting. Well, let's keep up. Let's back it up here. We are on, where was this? Moonbeam, yeah, CD, Moonbeam TGE, and then there we go. Okay. What is going on? Bytes. Interesting. One more time. So a new release just was brought out as I updated my CLI. And I'm sus that might have done it, which is fine. Yeah, ID field, something about that. Big int with string. Bytes. So yeah, this is a bug in the new release, which is okay. Live coding is fun. Let's go ahead and I will get this subgraph set up in time. But right now what I want to do is let's go ahead and deploy. We're going to try something different here just for the sake of education. This will be fixed by the time this video comes out. Okay, I'll ping my team about this. But what I want to do is just for the sake of education, let's go to this CryptoPunks smart contract. It's the exact same process for any subgraph out there. And any smart contract out there, we'll just do this on mainnet, but it will absolutely work once I ping my team about that ID issue. So sorry about that. Let's go ahead and go live to CryptoPunks smart contract address. And we'll find this on Etherscan. There it is. Boom, boom. And let's just do it from here. Let's go. No, we're going to go here. List. Okay, we'll go CD back, make dir live demo Moonbeam, CD live demo Moonbeam, and then let's go ahead and try this again. We're going to get some reps on this, everybody. Clear subgraph. Moonbeam, see CryptoPunks demo. Just for the sake of education, we're going to make this work. Okay, so same process through here. We will graph init in this file. Ethereum. There we go. We're on mainnet. We've got the contract address. Oh, no, that's not it. Of course, we'll do this. Clear. Nothing like live coding, right, buddy?
You're doing amazing.
It's okay. That is my job. Cold sweats included. Okay. So once again, Etherscan, it's not returning, not returning. We'll keep on trying. Come on, buddy. There we go. We got it. Okay. So we got start block and we got CryptoPunks market, which brought it in. We already went through this. All right. Excuse me.
Maybe there should be like a debug line saying like, hey, do you want to retry? Like, it's very likely that the block explorer is just refusing this request and you should actually try again or something.
Right. That's actually, you know what? I'm going to bring that to my team too. We got two things from this today. This is why I do workshops, just because it's like, sometimes you get ideas. Just doing this. So this is good. So we were in studio and let's just close this one so I'm not getting confused. And we've already authenticated. We'll CD into there. We will code gen and code build, type safety and the build. And then we will deploy the 0.0.1. And it's compiling and this should update unless that bug goes through. Did not. Okay, cool. So I'll have to talk with my team about that. That's okay. Here we can see the build is complete. We have the endpoint. This is api.studiothegraph.com. This goes to a centralized indexing, development, and querying environment that the graph provides. And we can see right now it's already indexed all the way to chain head. The reason being it went from basically 0 to 100% very quickly is because this CryptoPunks smart contract has been indexed to death. And if it ever sees an identical smart contract with no transformations on the subgraph, it'll just copy paste because it's the exact same data. But if I was to change, let's say, our code here, there we go. This is the one we want. Purple. Remember purple. And we were to make one small change. So let's say we'll change it to, let's say, 6. Just one small change. And create a new version that we want to deploy. Graph deploy, version 0.0.2. Now we're looking at a different smart block, start block, excuse me, smart block. That's a new one. And we could see it's 0.0.2, refresh, and there we go. So now it's indexing. This is a more realistic scenario when we're going very, very back to the beginning, and it's going to index all the way through. It's going to count us all the entities. So here we are in our subgraph that we built together. Before we go in and start sending queries in the playground, before we start really understanding these details and how to mess around here and the versioning control, that type of stuff, let's go into the code itself. And we'll look at the 3 main files. If we remember the 3 main files, they are subgraph.yaml, which is the manifest. They are also the mappings file, which is generally called the mappings file in the subgraph. That's where the transformations occur. That's always in the SRC folder. Then finally, we have the schema.graphql, and this is the database. So we have a lot of control here. We essentially have the manifest, which is the direction of where we want to point our subgraph. We want to look at the CryptoPunks market smart contract. We want the address here. That we populated through the CLI, the ABI and its name, the start block of where we want to start looking at the data, and the mappings. How do we want to do our transformations? Where is our data coming from and where is it going to? That's really in the mapping. So these are the entities in our database. These are also named the same names as the events that are being emitted from the smart contract. So if we look at the event handlers, we can see, hey, if an event is emitted, the assigned event is emitted, we're going to trigger the handle assign event. That is triggered, and whatever is in this handle assign event handler is going to populate the assign entity in the database. So that's kind of the workflow here. You want to look at the event, the name of the event, and the trigger is automatically populated, and then it goes into the actual database. And let's trace that, shall we? Let's take a look at the transfer, or the punk transfer. The punk transfer is going to have a little bit more data, as we could see. More data, or it's just different data. I think the punk transfer is more accurate, as I recall. And let's see this. Well, anytime there's a punk transfer being emitted from the chain, let's see what the handle punk transfer looks like in the handlers. So we go to the mappings file in the SRC folder, and we can see the handle punk transfer. This is where people get super creative with subgraph development. This is where the transformations can occur on the data. Let's go from over a high level, kind of what we're looking at here. This is the handler. It's a function that takes in the event. That is the punk transfer event. This is automatically built by the CLI, which is quite nice. There's no return here. We're not trying to return data. We're just trying to populate a database with this. We create a new entity in the database of the type punk transfer, and we give it an ID. Whatever we pass into this is the ID of that entity in our database. And it automatically takes the event transactions hash and concatenates that with the event log index, and it returns a bytes object. If we are able to have our IDs in our database be of the type of bytes, it makes them much, much, much more performant. We can also just change this to, into a string. We could change it to whatever we prefer. It just, honestly, it's just best to have it be bytes. We could say, string, and have it be whatever we want, but just it'll kick us out because it's not that type that's doing type safety stuff. So just know that bytes is best here for performance in our subgraph, our database. Then from there, you can see we have all these entities here, and we're creating all these properties on these entities, these from, the to, the punk index. And funny enough, they take the exact same name as the events being emitted from the chain. We have this event, the from, and it's going into the from part of the database. If we have a to, it's going into the to part of the database. And the event punk index is going into the database. Now, finally, every single event also has some metadata that's always emitted from every single event, and we also store that too. In the entity, the block number of when this occurs, we understand the number of whenever this event was emitted. We also understand the exact timestamp when this event was emitted. And we also understand the transaction hash that triggered this event to be emitted. So we get some metadata on every single event, and that is quite nice. And then we finally save that entity into our database. Now here we could do math, we can do lots of really cool transformations. We'll look at that a little bit on an extended subgraph, but for now, that's generally how every single handler is built. There's an ID that's passed into a new entity, then we do stuff with the event data, and we pass it into the database, and then we save it. That's basically what they all do. Any questions on that there, Kevin?
No questions.
That's good. Cool. All right, let's keep on going. So finally, we're in our database, and we see here, let's put these side by side just for the sake of teaching. We see the punk transfer database right there. We have the from going to the from. We have the to going into the to. Hey, it's just passing right in. And the ID is bytes, which is very nice, and we like that, of the entity itself. And we have storage in our database, and we're ready to go from there. So that's essentially it. There's so many more features these entities can have. We're not going to go into that. There's so many more features that these handlers can have. We're not going to go into that. This is just an introduction. I'm happy to teach that another time. Kevin, if you think it's another time to go into more advanced stuff, but right now, just understanding how that's passed is good enough. Let's get this to chain head just for the sake of, well, no, I think we can send some queries right now. Just, yeah, the data is already in there. Let's send some queries to the subgraphs database, and we'll look at the punct transfers. Now, it's not the chain head, so we're not getting fresh data. We're only getting data up to this point. So just know that if you're sending queries early, that's a thing. And we were looking at the punct transfers. So we want the first 10 that are in the database that we see, and it's not really going to be organized. We'll just look at who's it from, who's it to, and the punct index, and we can get that data back. Oh, still indexing, so we're not there yet. Sometimes it takes a few minutes to be able to organize all the data, which is fine as it starts. Let's see if any other data is in here. Let's look at the first 5 transfers. Are we getting anything in here?
Would it change anything if you went back to version 0.1?
Oh my gosh, you are the man. Look at that. That's why pair programming is the best. So yeah, let's go to punct transfers there, and let's see what data we're getting back. There we go. So thank you for pair programming there, Kevin. That was great. And we're already into versioning control. So we can see right here versioning control. If we want to send it to a specific endpoint, well, 0.01 is already chain head. That's great. If we change to 0.02, that'll change that endpoint right there. This latest will always go to whatever's latest, even if it's not the chain head. So just be aware if you're sending your queries to a different endpoint. I prefer to always use 0.02, 0.03, be explicit in my code if I update, if I can. That is a good introduction, I think. I think we've done enough on this subgraph. There's a few other things in the presentation that I think are just helpful to go through in terms of like things to be aware of. When we're creating entities in our database, kind of remember how our database is being shaped. It's these things, how we're storing information, how we're passing information into it. It's good to have entities that we build that are custom that we can start passing data in. And a good entity to create is a contract. What contract are we indexing? Represents the actual the collection, the actual address, the counts, the owners. The account, who's interacting with the smart contract. A lot of the tos and froms, we're going to be able to actually gather that information in our subgraph and say, hey, let's store that data as an account, and we could do some cool stuff. NFT, subgraphs are able to gather off-chain data too. They can get it from IPFS, and they can index data from Arweave. So if anything is stored there, feel free to index it and pass that data into our database too. Interfaces are great. Metadata, that's the file data sources. We can grab information from files. See which NFT with a certain trait being stored on IPFS is the most popular, and we could filter by that off-chain data, which is pretty damn cool. So a few other things that are important. If you are getting into subgraph development, these, not subgraphs, thegraph.com, if you want to read more about kind of like next steps, I wrote these with the help of a few other professionals on the team. These are subgraph best practices, subgraph best practice 1, 2, 3, and 4. These are really, really helpful for just understanding how to keep our subgraph super performant. So I would go through these, read a little bit more about the next steps and making them performant, and do that before you start adding new features. Because sometimes people add new features and they extend out like crazy, and then their subgraph slows down, and then they've built on top of code that is difficult to change. So best to know best practices before you get into tons of new features. And these are some of these features: immutable entities, aggregation entities. Those are really cool. Link entities, relationships, how to do relationships properly, making sure that it's performant. Helpers, that's cool stuff. So document your schema well. Anytime you're developing your subgraph and you think, hey, I want to go ahead and decentralize my data. Where is that subgraph? That is right here. Let's say I've developed 0. We're at 1.0. We're ready to go to production. It's still centralized on this development area. As we can see, it's still a development query URL. We then publish our subgraph to the graph network, and we publish it to Arbitrum 1. This is where the GRT exists and incentivizes people. Yes, we are indexing. Ideally, this, of course, should say Moonbeam, but we'll get back about that error. But it's indexing data on Ethereum, and then we want to publish and incentivize people that use the GRT token on Arbitrum, and then we provide GRT to incentivize people, to incentivize action. We could say, hey, 1 GRT, probably not going to get a whole lot of indexers on there, but 100, 1,000 GRT, whatever we are able to do, and get 2 indexers on there, 3 indexers, essentially hiring companies out there around the world to index your data and not just have one company do it. Just you're paying for companies to get to work out there. So anyways, that is the quick start to subgraph development. If there are questions, I did want to go over, let's see, the CryptoPunks subgraph. Remember I told you there was more extensions on a subgraph? I remember learning subgraphs. This is my favorite subgraph to learn because it's a little bit advanced, but it's not super advanced. I would go back to this subgraph if you really wanted to understand the subgraph.yaml, the mappings. Remember I said the mappings, people can get quite creative. And that's very much true here. I believe this is the main file where Jerry, I got to know Jerry. He got quite creative with his transformation. So, I mean, you could see he's doing enums. He's doing some mathematics, some checkers. He's checking the data. If, else if, he's doing some logic. So he's going hard in the paint in terms of what he's doing with the data, which is quite impressive. So, throw this into ChatGPT, tell it, hey, I'm learning some stuff. By the way, there's been an announcement about AI and the graph coming together. So take a look at that. We're going to have we essentially have decentralized compute already going with our indexers around the world. We're also opening up the door to have decentralized compute and a tokenomic system that already works. We're just adding a new feature set to our decentralized indexing. So that's another announcement. But anyways, that is quick start into subgraph developing. If anyone here is curious about joining the graph ecosystem, there's of course always jobs, network roles, community. If anyone wants to just learn more about subgraphs, I'm there. And then also Q&A with me. Any questions at all from you, Kevin? How'd that go? We're a little bit over, not terribly over.
Oh, this is phenomenal, Marcus. This is sick. And I'm especially appreciative that you took the time for both. You combined 2, into one, showing us both working with existing subgraphs and building our own. And this is giving developers and viewers here a tremendous head start.
Awesome.
So I'm very grateful for that.
Awesome, man. Well, I'm going to stop sharing my screen.
Wait, sorry. Just one thing before you stop sharing. I just wanted to ask if you could put up the link for the sample repo, just in case people want to get started.
Yes.
Like maybe they make it to the end and they're just going to get started on the video on the work now.
So if you go to my GitHub, the subgraph dev workshop is the one that we just went through. The subgraph query workshop is the one that we started with. So, and also the slides are all in here. You'll recognize this one that we just went through. Once again, we did the published CryptoPunk subgraph. I probably have to, he probably has to upgrade these links here. But essentially, this is the information here that we went through in the slides. And then also the query workshop, where we just go ahead and assess subgraphs in the graph network. Mostly this repo is going to be just good to drop into if you're using React Apollo, Vanilla.js, Flask, or even Graph Client. Graph Client is quite powerful. It's a more, we'll just say it's a powerful way to query lots of subgraphs all at once. So that's built by a core development team in the graph. So anyways, did that filter, did that go through all the questions? Yeah.
Perfect. Okay. Yeah. And the last thing is just that extra reminder for folks to upgrade any hosted subgraphs that they have, right? Go to thegraph.com.
It would be in docs and then upgrade. Let's, I believe, so go through Sunrise upgrading to the graph network facts. If you want to read more about upgrading, that's going to be great. And upgrade and existing, I believe, upgrade, how to upgrade index, or so many upgrading docs we have in here. Upgrade guide. Nope, that's the wrong upgrade. I've shared this in the upgrade. Upgrade from the hosted service. Nope. Where is that? Billing. I know there's the video. Here it is. They've actually combined the docs. That's what happened. Before this was a different location, and they just brought the docs right here. So how do I upgrade my hosted service subgraph? here it is for the video, and it literally walks you through the process of upgrading. It literally takes 2 or 3 minutes.
Oh, fantastic.
Yep.
Thank you so much, Marcus.
Of course. So yeah, Kevin, if there's any desire on your end also to come to our builders office hours, I'm more than happy to have you guys come on and share about Moonbeam. And I know we have a lot of subgraph developers out there, just understanding your chains that you have. We're happy to help. And anyone watching out there, if anyone would like to learn more about indexing their data in a decentralized way that has truly been battle tested. The graph has been around for 6 years now, which is basically 50 years in Web3 time. And so, yeah, and also we're going all in on decentralization. We're really doing it, really proud to be doing it. And we are trying to find new and powerful ways to use the GRT work utility token to incentivize action, which is truly Web3. So, yeah.
That's incredible to hear. And of course, Moonbeam is very proud to be along, with this journey. And yeah, I'd love to join one of the calls at some point. I think I might be on a podcast at some point.
Awesome.
In the next month or two.
Oh, that's great.
With the graph. So we'll figure it out.
Love it. Love it. Love it. Love it. So yeah, really nice to meet you through this screen here, Kevin, and nice to meet the Moonbeam community. That's everything for today.
Well, thank you so much, Marcus. And if anybody has any questions or comments or what you'd like to see next, please do leave those comments in YouTube, and we read and look at them all, and we'll get you to the right place. So thank you so much for joining us here today, Marcus. It is much, much appreciated.
Awesome. All right. Take care.
See you.